Hello, ladies and gentlemen. This is Chapter 2.1, Nature of Matter. Through this section, what we're going to talk about is just the three subatomic particles found in atoms, how all the isotopes of an element are similar and how they're different, what a chemical compound is, and the two main types of chemical bonds. There should be a review from chemistry. However, we'll go through it pretty quickly here. So an atom is an incredibly small unit, basic unit of matter. Again, we can study atoms, but keep in mind the cell is the smallest unit of living things that we study. So cell is living that we can study the smallest thing, and an atom is another incredibly small, it's smaller than a cell. However, it's not living. The three parts to an atom are going to be your protons, neutrons, electrons. Protons having a positive charge, neutrons being neutral, and electrons having a negative charge. Protons and neutrals are bound together to form the nucleus. That's what's going to give the element most of its mass, while the electrons kind of float around the outside. The electrons are going to be the negatively charged. Like I said, they have extremely small mass, which means we kind of neglect them when we're thinking about the mass of an element. We typically take the protons and neutrons into consideration and neglect the electrons. Atoms have equal numbers of protons and electrons. They have no overall charge. If you have an extra electron, you have a negative charge because, again, electrons are negatively charged. So if you have more of a negative, you're going to be negative. When we talk about elements, an element is a pure substance that consists entirely of one type of atom. Carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. All those are different examples of elements. Isotopes are going to be the same element, but different number of neutrons they contain. Okay, so we can have carbon 12, carbon 14. It's still carbon, but it has a different number of neutrons. However, it does have the same number of electrons, so they all have the same chemical properties. So carbon 12 and carbon 14, despite them being isotopes and being different, they still have the same chemical properties. When we talk about isotopes, we can talk about our radioactive isotopes. Their nuclei are going to be unstable and break down at a constant rate over time. Now, this rate isn't exactly the same for every radioactive isotope. It's different depending on the isotope, depending on how unstable it is. And the constant rate over time is typically an average of how fast it should be breaking down. This is kind of known as its half-life, so how long it would take for half of it to be broken down. It gives off radiation, so it is dangerous, but we can use it for carbon dating. The age of very old substances, such as fossils, we can use carbon dating, which is a radioactive isotope, to detect that. Detect and treat cancer, kill bacteria that causes food to spoil, and tracers to follow the movement of substance within an organism. If you ever have indigestion problems where they can't figure out what's going wrong, they might give you this stuff to drink. It's kind of a chalky stuff. You drink it, and it's a radioactive isotope that breaks down in your body. It breaks down very quickly, but they can trace it throughout your body to see where you're having the issues at. Compound is going to be a substance formed by chemical combination of two or more elements. So water is an example of a compound. H2O, hydrogen and oxygen, two different elements, it forms a compound. Physical and chemical properties of a compound are typically pretty different from which the elements. So hydrogen has its certain properties, oxygen has its properties. Together forming water is completely different properties from which hydrogen and oxygen have. Salt, NaCl, is another example of a compound. And the type of bonds we're going to talk about are going to be our ionic and our covalent. Ionic bonds are formed when the electrons are fully transferred from one to another. So if an electron is fully transferred, you're going to create ions, which are either positively charged if it gets rid of that electron, or negatively charged if it's accepting that electron. And again, one loses it while the other one gains. One's going to be positive, one's going to be negative. Covalent is our other type. This is when those electrons are going to be shared. So water is an example of covalent bonds. Those hydrogen and the oxygen are covalently bound. They share those electrons. So the electrons travel around the nuclei of both atoms, and it can be with single, double, or triple bonds. Molecules are going to be the smallest unit of most compounds. So you can have an individual molecule of water, which again is very small. It's the smallest unit. A glass of water obviously isn't one molecule of water. There's many, many molecules of water in that glass. And this is going to result when two atoms are joined by a covalent bond, such as the hydrogen with the oxygen. Finally, we have our van der Waals forces, which are when molecules are close together, a slight attraction can develop between oppositely charged regions of the nearby molecules. So one that we're going to focus on is hydrogen bonding. Individually, not as strong as ionic or covalent, but it is the strongest bonds that the water molecules can form. So hydrogen bonding, which we'll focus a lot on in the next section, is going to be between water molecules. So within the water molecule is covalent bonds. Between water molecules is going to be hydrogen bonding. And hydrogen bonding is an example of van der Waals, which is just when that positive and negative aspect of the water molecule come into close contact and form those hydrogen bonds. That concludes this section of the notes. Our next section will be on the water properties and what makes water so unique. Thank you guys for watching. Enjoy the rest of your day.